Hello, hello, and welcome to Hot Girl Math. Today we have this beautiful problem right in front of us, and we are told to write the logarithm as a sum or difference of logarithms, to simplify each term as much as possible, and to assume that the variables represent positive real numbers. Okay, so what shall we do first? Let me just grab a color. I'm gonna choose purple durple or pink or purple or periwinkle. No, I think periwinkle is actually blue and anyways, purple. So based off of this problem, we can assume that we're going to be using log rules. All right, so we are going to be reviewing some log rules today. All right, so looking on the left-hand side, what do we have with this expression? We have the natural log and the cube root of e to the fifth divided by a squared plus 5. All right, so what can we do here? I think we can start by taking this cube root and turning it into a fractional exponent, essentially. And we can do that by using the root, which is 3, and it becomes the denominator, while the power becomes the numerator. So I'm going to rewrite this without the cube root, but everything else stays the same. So let's put 1 here for step 1. The natural log of, let's do parentheses, e to the fifth divided by a squared plus 5. But don't forget, we just said we're going to take that cube root and we're going to write it as a fraction, 1 over 3, with the root 3 in the denominator. Okay, perfect. So what can we do from here? I'm thinking we could still work with a similar thing of the exponent now, this 1/3. I'm thinking we can use what's called, let me just switch my pen here. Let's do like a more hot pink color because hot girl math, hot pink, you just gotta keep working with it. So I think we can use what's called the power property. And the power property says that if you have log, or in this case ln, so I'll just keep that as ln just to make sure we don't get any confusion here. So if we have the natural log of the base b, in that case it would actually be e, and we have a number to a power, we can take this p, or this power, and put it in front of the natural log. All right, the exponent inside a log becomes a multiplier out front, so right here. So with that being said, we will move this 1/3 to the front of ln. So it ends up being 1/3 natural log, everything else stays the same, e to the fifth divided by a squared plus 5. Amazing! All right, and make sure you don't write 1/3 up here because we just moved it to the front. All right, perfect. So, what can we do here? I'm noticing this division sign, e to the fifth divided by a squared plus 5. I think we can do something with that. Let's do, I'm really tempted to choose this rainbow color. I think we should do it. I think we should do the rainbow color. So for step 3, I hope this isn't like too overwhelming with the rainbow color. I just wanted to make it sparkly and fun. We are going to use the quotient property. Oh, this is very fun. Yeah, I like this a lot. Okay, the quotient property says that if you're taking the log or the natural log of a fraction, this fraction right here, e5 divided by a squared plus 5, you can split it into a subtraction of 2 logs. And what that would look like is if you had, just using, variables here instead of real numbers, if you had log base b to m over n, in which m and n are just numbers or variables, that can become log base b times m minus log base b times n. All right, so again, you are splitting the fraction into 2 logs, log 1 or log 2. But in this case, obviously we're using the natural log. So with that being said, let's go ahead and do that. So we just have this 1/3 out here, which stays there. And I'm going to write this in brackets. I'm going to put ln e to the 5th minus, don't forget about that second ln, again, because we're writing that twice, a squared plus 5 and n brackets. Perfect. All right. We're getting pretty close to writing it and simplifying essentially as much as we can. Okay, so let's see. I'm going to actually distribute this 1/3 in front of the ln and in front of both ln's actually, because we have the brackets here. So let me distribute as like a half step here, 3.5. So we end up getting 1/3 ln e to the 5th minus 1/3 ln a squared plus 5. Great. So last thing I'm kind of seeing here that I feel we need to do before we can say this is fully simplified is let's just take a look at this right here, ln e. What is this really saying? Well, every time when we have ln, there is always a base here. And that base is assumed and is always e. Okay, same if you had log of 10, the base here is always 10. But sometimes they just don't write that. So here the base is actually e. And when we have something like ln e to the e, we can just cancel this out. This just goes away. Same thing if you were to have log 10 to the 10, just cancels out. And what happens is you just bring down that 5 and replace it where ln e is. So let's grab a new color. Let's do red. All right, and for 4, we are going to just completely get rid of the ln e. So we'll have 1/3, bring down that 5, and remember there is a multiplication here. 1/3 times ln e. Okay, so we have to make sure we bring down that multiplication, or we keep that multiplication there essentially. We bring down that 5, all right, minus 1/3 ln a squared plus 5. And all we do now is we just multiply 5 times 1/3. 5 times 1 is 5 over 3 minus 1/3 ln a squared plus 5. And this is our solution, or our answer. This is the most simplified version of this. All right, and it represents positive real numbers, and we simplified each term, check, and we wrote the logarithm as a difference in this case. All right, thank you all for joining me. I hope this brought some, I hope you're able to solve it with me, and I am looking forward to working with you on the next video. All right, talk to you soon.